Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
We ended our previous video tutorial 76, where we generated time series data for each of those individual points. Remember, we've created 100 points, not random points, purpose specified points, and we generated a asset for that points that we saved in our assets in our Earth engine. We call up that 100 points, and then we generated time series data for each of those 100 points for our different variables. So we generated snow cover for each of those points on a daily basis from February to February 2000 to December 2023. And we have generated all sorts of data for those 100 points. We're going to continue with that trend, and we're going to take it almost to its conclusion. So it will be 1 or 2 video tutorials that we're going to work with. Remember, in many of my previous video tutorials, I always said that the work starts in Earth Engine. That's where we generate the data and the images. Okay, so the work always starts in Earth Engine, and then it progresses, let's say, for example, to Excel, to QGIS, and then also to RStudio. So in the next 1 or 2 video tutorials, I want to sort of take you through this whole process from beginning to the end. Now, it's very simplified. Obviously, there's a lot of nuance and intrigue to it, but just as a showcase, I want to just show you the pipeline, if you want, of this whole process. Okay, so I'm going to go to my script, my script that focuses on the snow cover, and remember, there it sits. Remember, I always run and I save, and I run and I save. Okay, so remember, the first thing that we did is we created a ROI. Okay, we created a ROI, and this is this blue area here. And we used it using our geometry imports, and specifically we used our Polygon function. Okay, so there it sits. Okay, so you can see there it sits. Easy. So we click on that, and we basically just draw our polygon, and then it will basically be generating itself as a variable. We change it that, and it has 13 different coordinates, and these coordinates refer to these particular turning points or shapes, or where the so these points here would be so that would be 1 coordinate, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe that's a 13 one there. Anyway, so there it sits. Okay, so then we generated and then remember, there's our 100 points, our maximum temperature points, and there it sits. It's got properties, where's columns, and remember, there's a type, it's a feature collection. So we generated that as well. Also, again, using our geometry import function, but the case we use the marker. But remember to switch on your, if you go into here, remember to switch on, it's a feature collection, to make sure that. Okay, otherwise I'll save it as individual points and not as a feature collection. So then we generated our, used our variables, and we generated various images. That's all in our layers here, etc., etc. So that's all the stuff that we've already covered. Okay, that's done. What I want to do now is to say, okay, we've got our region of interest, we've got our 100 points. We now want to generate for each of these 100. First of all, we want to generate for each of these 100 points a whole time series data of all these variables. Okay, so that would include the snow cover, the normalized difference snow index, all the data sets or databases that have time series data, we want to generate it that. So that would be maximum temperature, minimum temperature, snow, rainfall, all these variables that we're going to generate. So we're going to generate a time series for all this 100, for all the data sets that is in time series format. Okay, so that's one thing. Second of all, what we want to do then is to say, okay, we want to generate data for those data sets that are not in time series. Remember, elevation, slope, gradient, hillside. Remember, those are not in time series format. That's a singular point time series data. It generates a data set for a singular point, almost like a census, if you want to. If you want to. Okay, so that's not in time series format. So for that, we're going to generate the image, and then from the image, we're going to calculate. Identify the value for that point for that specific variable, but that would be a once-off value. Okay, so two things. We want to generate a time series for data for each of these 100 points for those data sets that are time series, and then we want to generate the images for this region of interest that we want to use to generate a singular value in for our 100 points. Okay, so I hope that makes sense. So I've created the second script. So the first thing is I need to obviously bring in my region of interest and my 100 points. Okay, so I don't want to continue working on this particular script because it just gets too much. It is just too big a volume, and therefore it makes the script slow, it hangs, it gives you errors, etc. etc. So I don't want to continue with the slot, although you can if you want to, but I want to generate a second script or second project. Okay, and so this is it. So first thing I have to do is I have to bring in my region of interest. Okay, so I have to bring in my region of interest. Remember, my region of interest is a polygon. I've created it using this polygon function, this draw shape. There it sits, the region of interest. If I open that, you'll see it's a polygon geometry. It's not a feature collection. Okay, it's not a feature collection. So that implies it's not saved in my assets. I haven't saved it in my assets, meaning I can't import it into my new script because it doesn't sit within my asset. I haven't created the asset. I've only created the polygon, which is in this particular script. So for any other script, that polygon doesn't exist. I cannot bring it in because it's not existing in my assets. So the first thing I have to do is I have to reproduce or recreate this polygon in my new script. Okay, and then what I do is I want to convert it into a feature collection. Okay, because then I can save it as in my assets. So the first thing, so what we have in this region of interest, we have all our coordinates. So we're going to just copy and paste these coordinates. Okay, so I copy and paste all 13 of them. Okay, so first thing I do then is within my new script, I copy and paste these 13 coordinates, and there they sit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And you'll see it's exactly the same. So if I go to the first set of coordinates, it's 18, 6, 18, 6, 990, 18, 6, 990, minus 33, 6, 7, 6, 9, minus 33, 6, 7, 6, 9, etc. Okay, so there's all the 13 coordinates. Okay, remember the format that you have to write it. And then I said to him, I'm creating a variable, and that variable is called coordinates, and that coordinates consist of these 13 coordinates. Now, the variable name, that one there, is up to you. You can decide ping pong, lollipop, whatever you want to call it. So for simplicity, I'm just using it coordinates. So I'm bringing that variable into my script, which is the coordinates, and I'm giving it a name called variable. Remember just the format, okay? The double closing bracket here, which is related to that one, a comma after each one. And then I go to my tell Earth Engine to say, listen, I want to this coordinates, okay? I want to convert it into a polygon. Okay, so I'm going to convert it into it's a polygon. Okay, and basically I say my ROI, which is the name of it. Again, you can use any. Is Earth Engine, EE, geometry, because that's what we're working with, and this is a polygon, okay, and my polygon has these coordinates, okay, so that's my polygon, that's my geometry that I'm going to use, and I'm giving it a name called variable. Then here, what I'm doing now, I'm going to save my ROI as a feature collection, okay, so I'm saying here, I'm creating a feature collection called snow locations, okay, and again, that's up to you, and that is Earth Engine. It's a feature collection. So this polygon here that I've created, this polygon based on this coordinates, which I call region of interest, I am saving that, or I'm converting that into a feature collection. And then I'm saving this feature collection or exporting this feature collection to my assets. Okay. So first of all, I create a variable. In this case, I created a variable called coordinates. The coordinates have these 13 coordinates, which gives me this polygon. It gives me this polygon. Okay. This one here. This polygon here, which is the 13 coordinates. And then I am saving, or I'm generating a feature collection with this polygon, with this 13 coordinates. I'm creating a feature collection, and then I'm exporting that feature collection to my assets. Okay, and there it sits. Remember, if you press run, you'll see it will say you there's a snow collections there. Remember, that's snow collections there. There it sits. You can see it's a feature collection. It's a table. It's got that little, almost like an Excel type of thing. So that's called a table, and basically you just press run, and then at some point you're just going to go and refresh. Once it gives you the blue, okay, meaning it's done, it's uploaded, it's exported, you basically just press refresh, that's the refresh button, and then you go and look for it. We call it as snow locations, and we just go down the asset list. We go down NNPOQR snow. Okay, there we go. There's snow locations. Okay, there it sits. So if I open it by using this little button here, the share button here, or just double click on itself, you'll see it will open up and it will show its face now. There we go. There it sits. Okay. Features, it's got no features. Properties, it's got nothing, etc. It's a polygon with 13 coordinates that we've converted into, first of all, a polygon, and then into a feature collection, and then we saved it. And then I simply just import it. Straightforward, nothing to it. And there it sits, snow location. And now you'll see it's a feature collection. Where I go here, it's a polygon. You see there? It's a polygon. And now I've created a feature collection. It's got columns, nothing. Remember, I can now add columns to this. Okay, and we've done it in one or two of our previous video tutorials. We can now create a host of columns by using our random column function. Okay, so we can generate. In this case, it's just one. Properties, it's an asset size 7214. Remember, it's not it doesn't have a starting point. It's not time series. It's just a polygon. Okay, and then I bring in my maximum temps, which we have already saved as an asset. So I bring that also in because that's the individual points. Because remember, there's two things that I want to do. I want to generate data, time series data for each of these 100 points for those data sets that are in time series. And then I want to generate for those data sets that's once off, that's a particular image. I want to generate an image that I can export. So that's the two things what I want to do. But first of all, as I said, I had to generate my region of interest with my polygon, which is my boundaries of my region of interest, and my 100 point, or is it 50? Sorry, is it 50 or 100? 50. I think it's 50. Anyway, I don't know where we did 100 somewhere, but maybe it's 50. Okay. So first of all, again, I'm going to use my triplets function, my triplet script to generate my time series. Okay. In this case, I'm using my climate. Okay, I'm using my climate data sets. Now remember, the climate data sets also from February 2000 to March 2022, I think, if I talk under connection. So I'm just going to use a moving average method to generate it up to December 2023 in Excel. I'm going to do that in Excel. So that's not a train smash. Okay, so in this case, I'm going to generate a time series format for this band, which is VS. Now, if you go into the data set itself, you'll see that under bands, VS is wind speed. Okay, wind speed. Remember the scaling factor, né? Remember in that data set, all of those bands have different scaling factors. You must make sure you have the correct scaling factor. And I'm just running this. Remember, we've been through this triplets script, so I'm not going to go through them all. Couple of things. Make sure all the places that you have the correct band or the correct variable. Okay, and remember, this is your point. Ne? This is the point that you have to make sure that's in your table. Ne? Remember, here we deal with the individual points, so it sits there, it sits your point. Remember, we generate a column for each of those ones, there it sits. So those are a couple of things that you need to remember, but we've done it in the previous video tutorial, so you can just go through it. So make sure that you, in the script, have the correct time period. Okay, make sure you have the correct band. Make sure you have the correct scaling factor. So it's 1, the correct ID of the data set. 2, the correct time frame. 3, the correct band. 4, the correct scaling factor. Remember, if there's no scaling factor, just make it 1. So that's 4. Okay, and then remember the other important thing is to make sure you have this column that you've generated within your points. Remember, and we've done it in the previous video tutorial where we generate that point. So those are the 5 things that you have to remember. And then you simply just export it, and you export it as CSV. So you export it, and there it sits. VS, okay, because remember that's a description. VS, there it sits, you run it. So now you want to generate, let's say, maximum temperature. So all you do is you change that to, rain. Rain is PR. So you change it to PR. But I think it's 0.001 is the, or 0.01 is the scaling factor for rain. You're going to change it there for rain, which is PR. Then you're going to go, there's another place, there's 3 places you have to change it. In the script itself, the point stays the point, and you just change that now to PR as well, and PR as well, and you run it, and it will come sit there. Let's run it again. You'll see there it sits at PR, and now you run it again. So that's how you generate the different the time series for each of these 50 points. But remember, it's only for those data sets that do have time series, that's based in time series, which is your snow cover one, your normalized difference snow index, and all your climatic variables like maximum temperatures, minimum temperatures, etc., etc. So all the data sets you can think of that you want to bring in here, remember, don't bring things that's got nothing to do with it. Okay, so only those variables that you want to eventually model or bring into your empirical work or your analysis. Only those variables. And in this case, it's snow cover, normalized difference, snow index. And my maximum temperatures, minimum temperatures, participation, wind speed. So those are the 5 or 6 that I want to do in time series. Okay, so I rerun and rerun and rerun this code every time, just changing those parameters. Okay, every time changing those parameters, and it will generate then the 5 different CSV files, and I just merge those CSV files. Okay, I'll show you now. And then as I said, there's images that, or data set that's singular, that only have one particular value. It's not time series. It's a cross section, if you want to call it that way. And that's, for example, if you go down here, this is, for example, if I go down, sorry, I'm just export where they are now. Then the first one, sorry. Are they still in the first one? Okay, sorry, they're going to be in tutorial 3. Sorry, editor. So I'm just going to go to my Snow 1 tutorial 3. Sorry about that. So I go down, I'm going to go look for my snow tutorial 3. I'm opening it up and I'm just moving it to that side. And they, nope, also not in this particular one. I don't know where they are, but anyway. So you generate the images for that, for my elevation. So all my, call it topography or geography variables like elevation, hillside. We've done it in the previous tutorial. So I generate the images and then I just export them, and I just basically export them. Okay, so they're going to all sit in here. I think somewhere here, you see there, I have climate band X, climate band M, climate band R. They are all, M is maximum temperatures, R is rain. So they're all there. Where are they? Are they more to the top? They must be somewhere. So am I missing it? Am I missing it? They're all climate. Climate. I don't know where they are. Anyway, we'll get to that. Okay, so I export them to my, using the script. Remember, using the script, I export them. So this would be export X, I can remember, is the maximum temperatures, M is minimum temperatures, R is rain, V is wind speed. And there's my normalized different snow index in a medium. So I export all of these images. Remember, they are once-off images. They're singular images. So I export them into, remember, if you export them here, these ones, it goes to your Google Earth, Google Drive. And from Google Drive, a Google Drive folder, you just export it into your desktop or your laptop, and then you open it in QGIS. So I've done all that stuff, and and there it sits. They're all in my QGIS now. You see, so there is my, let's go and have a look at it. You see, there is my elevation. There's my elevation image. There is my hillside image. There's my aspect image. There's my terrain image. There's my terrain. So those are my, call it topography variables, which is my terrain, my aspect, my hillside, my elevation, and my slope. Remember, we've done all these images in Earth Engine as well. And I just generated random colors for them. Okay. I also exported my median environmental variables. Okay, so for example, maximum temperatures, minimum temperatures, rain, and wind. Okay, so I can play around now with these variables or these images in QGIS. There's my normalized different snow index. You can see there's the blue one here, and this is my snow cover index. That's my snow cover index. Let's just take it off. Let's just take that off. There's my snow cover index, and I've put the values from 100 to 407. So I go to properties and I make the minimum 100, because below 100 it doesn't indicate snow. So I only want 100 locations, or pixels, the correct word, if they have a value, a DN of 100 or more. So all the pixels with a DN of less than 100, it's not included. So there they sit. So these are the snow locations. Okay. Now I brought in an Esri satellite image just to position these snow at the right places, to see that these snow are actually sitting at mountains, just to visually identify locations that have snow. And basically, I just right click here and there's my browser panel. I bring in my browser panel, and in my browser panel, let's go. If I open the browser panel, you'll see here at the bottom, it will say there's my S3. There's a standard terrain one, there's a Google satellite. So I just double click on it and I can bring that in. Okay, so that gives you a nice little background or a backdrop to your data. So you can visually identify where they are. Okay, so that's my snow cover. So all of these images are raster images. You see, when they have these little blocks there, the dark blue and the light blue and the white little squares within this block, they are what we call a raster image. You see there, it's called a TIFF, and specifically a GeoTIFF. Okay, so these are raster images, and we generated them in Earth Engine. We've generated in Earth Engine. You can see there we've generated it and we exported it. So they're all there. So that's what I'm saying. It starts with Earth Engine. And then I put it there. Now, as I said, aspect, hillside, elevation, slope, these ones, terrain. So this topography variables, these ones here. Sorry, these ones here. Just highlight them. Keep in the shift, press in the shift and left click on your mouse and you highlight them all. They are once off. So there's no time series of it. It's a once off image. Okay, but we know that wind, rain, minimum temp, maximum, normalized difference, snow index, snow cover, they are all time series. So what I've just basically done, I've generated a singular image and I used in my environmental ones, max and net, I used a medium reducer, and in snow cover I used the sum reducer to generate a singular image. So this maximum temperature, this image here, is a median image of all the monthly images from February 2000 to December 2022. So this is a reduced image, meaning I create one image from the image collection. And the image collection has X amount of images from February 2000 to December 2022. You can calculate how many that is. And you just use the reducer, which is a median. And you'll see there, if you go into my code, you'll see they're all based on, you'll see there the median. All based on the median value. Okay, and obviously correctly scaled. Okay, so that's all of them. And then I did the same for my normalized difference snow index. It's also median reducer. And then for my snow cover, as I said, this one here, I use the sum because I wanted just to magnify snow. So I get a cumulative value. Otherwise, it's very, very difficult to identify location. So play around with it, but I use, so this is a sum reducer. All these other time series of image collections, I've used median as my reducer, and with the topography, it's once off, so there's no need to reduce it. I just said, so there's all my images. Okay, there's all my images. And together with that, I've generated obviously time series data for all 50 points. Okay, but what I don't have is the for each of these 50 points, there they sit. For each of these 50 points, I don't have values for my topography. Remember, I've already generated the time series data for this 50 points for my snow cover and my environmental indicators. That I've done. That's done. And to show you that it's already in Excel. Okay, so you see there's my snow SN, my snow in time series format for all my locations. There's my locations. Let's make sure. No, it's 100 points, 100 locations. Yeah, there's 100 locations. Location 1, location 2, location. Remember, that's the point. That's the column that we've randomly created. That's very important. So there's my locations. And then for each location, I've got snow cover in time series format. You'll see there from February. Now let's check it to the end. And then what I've also done is, before I go to the next variable, you'll see that's 2008, 2009. Let's go a little bit. Remember, initially this was monthly, daily. So I've converted into monthly, because otherwise it's just too much. And then for each of these variables, like for snow cover, I created a sum variable. sum for everything. I created an average. I've created a median. And I've created a coefficient of variance, which is just standard deviation divided by the mean. See there? Standard deviation, D4 to KD50, KD4, that one there. And I divided by KF4, which is that one there. So that's a standard deviation. So I just generated a descriptive statistics for each variable. And the reason I do that is because I can't use my time series with my topography variables. Okay, so I have to use cross-section work when I bring in my topography. So that's why I do this stuff. There's my maximum temperatures. Same thing, February for each location. And remember, these are basically just the dates, and on my rows and in my columns, it's the time series, and in my rows it's the locations. So I've got snow, I've got maximum temperatures, and I've got minimum temperatures, and I've got rain, and I have wind speed. And for each of those variables, I created a sum, an average, a median, and a coefficient of variation. Okay, so that's my 4 variables that I've created in time series format. Okay, so what I want to do now is to say, okay, I want to generate for each of these variables also its associated topography value, but that will be a once-off value because these variables, as I said, is only a singular image, not a time series or image collection. So that's what I'm going to do in the next video tutorial, is to continue with this, and that will take us to the next step of the data set as a whole, and then playing around a little bit with it in RStudio. Okay, so yeah, thank you very much for joining me. It's been a long time. I think this first time in 2 weeks again, and we've been so busy the last 2 weeks that I haven't had time to do it, but we're up and running again, so more to follow. And I said I really want to start working on the whole pipeline now, and I want to show you from the beginning to the end how this whole process works, and where is the connectors, how do you connect all these different programs together so that it's one seamless pipeline. You don't have to struggle. It just runs very smoothly from one program to another program, and how you basically just add and add and add until you can basically do quite sophisticated work. But as I said, it always starts with Earth Engine. Always starts with Earth Engine. Okay. Yeah, so thanks for joining. Look forward to the next couple of ones that's coming. We're going to slowly start moving, not away from Earth Engine, but we're slowly going to start incorporating other programs into our video tutorials as well. So focusing a little bit less on Earth Engine and more on other things. And as I said, it's to put Earth Engine in context of, let's call it a holistic approach of doing this work. Okay. Anyway, thanks for joining. Much appreciated. Remember to like, to subscribe. Please subscribe. Please subscribe. To share the video. Give me some comments. I really appreciate comments. I get very interesting questions and things. I thoroughly enjoy it. And then I'll see you on the other side.